Hello students! Today we are going to learn about interval and set notation. We're going to learn what these symbols mean, and then we're going to learn how to use these symbols to represent numbers. First things first, what is interval and set notation? Why do we need it? Basically, we need intervals and sets just to represent a long range of numbers without having to write down each number itself. Okay, so it'll look something like this, and this particular example is what we call set notation. We'll look at interval notation in a bit. Now to look at set notation, I want to pop over to this website from Math is Fun because it gives a really good image of what all of this notation means. So to start any set, you always need curly brackets. Okay, the curly brackets tell you where the set begins and ends. It has to be in curly brackets. If it's not in curly brackets, it just confuses people to what you're talking about. Okay, curly brackets, everybody in the math world knows it's a set. So inside of the curly brackets, you'll have two different sides on this bar here. The left side tells you what you're talking about in the set. Okay, so x being on the left side is defining our variable for the set being x. It's saying that our rule is going to deal with x. Okay, what you see on this side, this is the rule side. Okay, so this is the definition, this is the rule. And rules in our particular use of it will typically be written as some sort of greater than, less than, greater than or equal to type statement. Okay, so our rule in this case is that all of our x values have to be greater than 0. Now remember, this is greater because it's facing the x. You can think of it as like a little face that wants to eat the x because x is bigger, whatever works for you. And then this bar here just kind of separates the variable from the rule. Technically in math it means such that. So the set of all x such that x is greater than 0 is what this notation says. So what we want to do now is remember how to graph this on a number line. Okay, now in this case we're not talking about 0 anymore. We need to think about what our rule says. This rule says it's a set with x as a variable such that x is less than 3. This time the symbol's facing away from the x, so we want all the x values to be less than 3. What I always do first is I'm going to plot my critical value or my boundary. So we want any value that's less than 3. So I know I'm going to have to deal with 3. Okay, now on a number line, if you remember back in the day, everything on this side gets smaller, going to the left, and anything on the right gets bigger. So this would be like 4, 5, and this would be like 2, 1, 0, -1, so on and so forth. You don't have to write those in, but I'm going to for the first example. Okay, but 3 is our critical value here. Now, if we want to graph this on the number line, we don't only want the value of 3. This says we want all of the x values that are less than 3. So all of the x values that are less than 3 are going to go to the left on the number line, or get smaller. So I just want you to shade those in. Okay, the last thing we need to remember is what we're doing at 3. This is an interesting problem because it says x is less than 3. It doesn't say x can equal 3. It's anything less than 3, which means that 3 is not included. So to not include 3, we're going to put an open circle at 3. Open because anything in that circle is not part of our set. Okay, so this would be the final answer for how you graph this particular notation on a number line. Okay, I know we want to write it using alternate notation, but we need to look at what the alternate notation is before we can do that. In problem number 2, we're looking at a list of numbers in what's called interval notation. So the first one was set, this one's interval notation. So similar idea, and we're talking about a list of numbers, but this one you're going to write the numbers in terms of parentheses and brackets. A little bit less going on here, but it still tells you a lot. Interval notation is good for writing all the numbers between a starting point and an ending point. So on the left, you're always going to write your lower bound or your lowest number, and on the right, you're always going to write your upper bound or your highest number. Lower bound, upper bound. So what this says is we're starting at -5, and we want all of the numbers going through positive infinity. So my first critical number is -5. I'm going to plot that on the number line. That's my lower bound. And then we want everything going towards positive infinity, which is the biggest number imaginable. So the numbers should get very, very big, like 100, 1,000,000, 1,000, whatever it is. So we start at -5, and we go to the right because that's where the numbers get bigger. Okay, this would be positive infinity. And if we went in the other direction and got really, really small, that'd be negative infinity. To finish off this graph, these brackets / parentheses are very important pieces to this puzzle. Okay, sometimes you'll see a bracket or both brackets. sometimes you'll see parentheses, or sometimes you'll see a combination like you do here. Anytime you have brackets, that means that value is included. So it'd be equivalent to saying like x is less than or equal to 5, for example. Anytime you see a parenthesis, that value is not included. Like the previous example when we didn't include that 3 because it just said x is less than, couldn't be equal to. So I guess you could also say equal or not necessarily equal to that value. With this information, let's look back at our interval notation here. We have a bracket on the -5, so that means -5 is included. We want that value to be a part of our number line. So instead of doing an open circle for not included, anytime you want to include a value, we want to close that circle up. Open circle, not included, close circle, included. Important details so people who are looking at your graph know what you're trying to say. Now, anytime you have infinity or negative infinity, we always put a parenthesis on that because you can't really include something that's not a concrete number. Okay, it's more of an idea of a really, really large number. All of this up here is infinity, so we're always going to put a parenthesis on that. Now that we know interval notation, I want to go back to the original directions and write the rule using alternate notation. So what I want to do is I want to take this graph here, and instead of writing it as a set, I want to write it as an interval, meaning I'm going to use parentheses and I'm going to use brackets. In order to do this, we need to look at our lower bound and our upper bound. So the lowest point on this graph, well, it goes on forever in the negative direction, so that makes our lowest point negative infinity. The last point on this graph, or our highest, or our upper bound, is going to be 3. So we want all the values between negative infinity and positive 3. Since infinity is one of our bounds, we know that that needs a parenthesis. Okay, an infinite value is not a distinct value that can be included. 3, on the other hand, it is a distinct value, but it's got an open circle because it just said less than, can't be equal to. So that one also gets a parenthesis. And that is how you would write this problem in interval notation. Let's do the same thing for this interval problem, but write it in set. A little bit trickier, but we know every set needs its curly brackets to start it out. We also need a variable to define our set. Now, I know this doesn't give us a variable, but since we're talking about a graph, I'm going to use x. So the set of all numbers denoted with x such that, that's what that bar means, and now we have to write our rule. So our rule has something to do with -5, and it's going towards positive infinity. So we want all the numbers that are bigger than -5. So that means x has to be greater than -5. Now, this is a filled-in circle, which means that -5 is included. So it's not just that x is greater than -5, but it can also be equal to -5. So we denote that by putting part of an equal sign underneath the greater than sign. This means greater than or equal to. To finish this off, we need to end with our curly bracket. So our set is complete, we've done our job, and we're good to go. That is all I'm going to do in this video. There's a couple more problems for you to think about. They bring up some interesting points about different kinds of rules, but I have no doubt in my mind that you'll be able to figure them out. Make sure you write down some questions, come to class and ask them, and I will see you later. Have a good night.